Hello everyone, I am Dr. Chander Pawar. Today I will be briefly discussing about sources of energy followed by refining of petroleum, and this is part of our induction program. So during my induction I have been attending some of my seniors lectures, and this is the takeaway from their lectures. So today I will be discussing briefly about refining of petroleum and what are liquid fuels and how they are synthesized, how this fractional distillation can be done, and finally the characteristics of a good fuel. Now these are the basically five modules which is part of our curriculum. So third one that is in our curriculum unit energy sources or fuels, followed by the battery technology. So this energy sources and battery technology has been categorized into two types. Part A, which speaks about the fuels, basically all the three types of fuels: solid fuels, liquid fuels, and gaseous fuels. And part B talks about the battery technology, especially what is the cathode, what is anode, and how that construction of battery can takes place, what are the types of batteries, primary, secondary, and followed by their applications. Now yeah, this is the pictorial representation of energy sources, all the three forms. We can see here coal upon burning, which gives energy in the form of heat, and liquid basically kerosene, diesel, petrol, etc. And here gaseous form of fuel, basically CNG, LPG gas, and many other methane gas, hydrogen gas, etc. So before going into details, why different types of energies and what is what emphasizes us to come up with the alternatives. Basically the growing population means growing demand. Day by day population is increasing. Population increasing means the energy usage demand is going up. So that is why we are always looking for the alternatives. Thermal energy, hydro energy, wind power, solar power, nuclear power, various alternatives we are looking all the time. That is because of the growing demand. So basically when we talk about these liquid fuels, basically it could be solid or liquid or gaseous. Upon combustion, any material which gives energy in the form of heat, that we can call it as a fuel. So basically fuels are combustible materials, combustion which happens inside the machinery. Okay, it's an internal process, not like burning external process. So combustion, internal process, and upon combustion there will be some byproducts like soot and smoke release, and along with that energy, that is which helps us for the vehicles. So now this fuel is basically meant for by carbon and carbonous materials and hydrogen. Okay, so main source of fuel is carbon and carbonous materials. In our second other alternative is hydrogen and hydrogen energies. Okay, now as it is represented, fuel carbon plus oxygen leads to heat energy. This is the energy. This is the energy. And whatever this carbon dioxide and water molecule given represented, those are the byproducts. So we are looking for this heat energy. Fuel that is in the form of carbon, upon burning with oxygen, whatever the energy is released, that is what we are looking. Okay. Now basically based on the occurrence, these fuels are broadly categorized into two types: primary fuels, secondary fuels. Primary fuels naturally occurring. These are the natural resources like coal. Coal we are not creating. For example, when we talk about Singareni Calories coal mines, which is located in Telangana, we will be digging and sending that for the NTPC, National Thermal Power Corporation, and upon burning that coal, steam will be generated, and that generated steam will be used for the electricity production. Okay, and that coal mines naturally occurring fossils, and naturally occurring fuel. So likewise, crude oil, when we talk about Gulf countries like Bahrain, Dubai, Kuwait, Saudi, all these Gulf countries are having rich wells of crude oil, and that crude oil as it is we cannot use for the vehicles. So once we refine, then only we can use that crude oil for our vehicles, petrol, diesel form. So that crude oil is primary fuel, that is fossil fuel, and whatever the extracted one, whatever the taken from the crude, purified one, that is the secondary fuel. That means we can see fuels which are derived from the primary source, that is nothing but natural sources. Those are coke, petrol, diesel, water gas, hydrogen gas, etc. These are the refined fuels. Secondary fuels are refined fuels. Primary fuels are fossils, crude form. Okay. And as I said, these are broadly categorized into three types. Solid fuels, for example, wood, coke, coal. Liquid fuels, petroleum and petroleum products like petrol, diesel, kerosene, etc. Waxes, grease. And gaseous fuels like natural gas, producer gas, water gas. Apart from this, CNG, LPG, liquefied petroleum gas, CNG, compressed natural gas. Okay. So all these comes under gaseous fuels. Now, so before going into the refining of petroleum and its applications, what are the characteristics of a good fuel? Fuel, it could be solid, it could be liquid, it could be gaseous. What are the characteristics that a good fuel should have? The fuel should be available with low cost, with that everyone can use. It should have less moisture and ash content. If impure fuel gives more noise, more smoke, and more soot. The pure the fuel, efficiency will be more and byproducts will be less. So a good fuel should have less moisture and ash content. Less moisture and impurity should be less. It should have high carbon content. Greater the carbon content, more the energy. Lesser the carbon content, that means more the impurities, the energy will be less. So now high carbon content means energy will be more. That is specifically in the form of heat, energy will be released more. A calorific value should be more. Calorific value is nothing but if we take a 1 liter of petrol or 1 ton of coal, after burning 1 liter of petrol, how much energy has released from that? Or after burning 1 ton of coal, how much energy has been released? That is a specific volume and quantity, right? 1 kg, 1 liter and 1 ton. Specific quantity. So from that specific volume or quantity of coal and petrol, how much energy is released after burning? That is nothing but calorific value. So any fuel that should have more and more calorific value. And it should be easily handled, stored and transported. Yes, as we know that petrol, diesel, kerosene, all these are highly pyrophoric. The word pyrophoric, which readily catches the fire. Which readily catches the fire. Fire sensitive. Okay. Pyrophoric means fire sensitive. So when we are transporting and when we are storing these kind of fuels, so we should be very careful. There should not be any fire accidents and there should not be any volatile kind of things. Okay. And the fuel should not produce toxic gases like carbon monoxide, carbon dioxide, like emissions which are harmful, which are leads to the air pollution. So toxic gases should not be released. Combustion of fuel should be easily controlled. Consistent ignition should take place. Okay. And velocity of combustion should be moderate. Yes, controllable, moderate. All of a sudden there should not be any burning of fuel. If all of a sudden there is a burning, then explosion may take place. So these are the major characteristics of a good fuel. Okay. Let me move forward. When we talk about specifically liquid fuels, petroleum, which is in the crude, petrol, diesel, kerosene, these are the refined one from the petroleum. Petrol is nothing but mixture of hydrocarbons. Okay. Diesel and kerosene are byproducts from this petroleum. Petroleum is crude, as I said. Okay. And what are the advantages of these liquid fuels? They burn without forming ash and dust. Okay. And they are used internal combustion. As I said, internal combustion is internal process. Burning is external process. Easily ignited and easily emission controlled. Okay. And less amount of air is required for the combustion. Why? Because it is an internal process. Loss of heat energy will be less. We can minimize that loss. They are easily transported through the pipes. Why? Because liquid in the state phase. Liquid fuels are having high calorific value than the solid fuels. Okay. And certainly there are some disadvantages. Care must be taken while storing. If it is volatile, petrol can easily evaporate. And sometimes they can easily catch the fire, pyrophoric. So, and sometimes they give hazardous and some odd odor. So, which is irritating. So, we should be careful about with these disadvantages. And here we can see one major company in India, ONGC, that is nothing but Oil and Natural Gas Corporation, which mostly help us to refine this crude, okay, and to extract these liquid fuels. Here we can see Petra is nothing but rock. So basically when we drill, a lot of earth crusts will be, layers will be there, and from those rocky layers, crust, we have to take it up by sending the compressed gas and hydrostatic pressure. We have to dig it, take it up, and this mostly petroleum comes from the rocky mass, okay, earth crust. That is why Petra is rock and oleum is oil. Okay, that is petroleum byproduct, raw material. And here we can see the composition of that petroleum. Carbon, hydrogen, major constituents, nitrogen, oxygen and sulfur, trace amount of element composition. Carbon, which is somewhere 80 to 87%, hydrogen somewhere 11 to 15%. These are the major constituents, carbon and hydrogen in any liquid fuels. As I said, petroleum, mixture of hydrocarbons. Okay. Now, here we can see mining of petroleum. As I have mentioned here some pictures, hydrostatic pressure and compressed air. Hydrostatic pressure related to liquid. Liquid compressed and pressure will be developed to take something up, especially for the natural gas digging purpose. Okay, pull up the natural gas. When we do this kind of drilling, there is a bore well, we will be sending compressed air. So with the pressure of this compressed air, whatever the liquidous materials are there in the earth crust, they will come up as water is coming up here. That is compressed air. And mostly these kind of earth movers like JCBs and procliners, earth movers, these hydraulic jacks, we can see here hydraulic jacks. We know that hydraulic brakes. Okay. The hydrostatic pressure will be developed within the liquid. Based on the hydrostatic pressure only this hydraulic jacks works. With this concept, hydrostatic pressure and compressed air, we can do the mining of petroleum, that is extraction of crude, or pulling up the crude, raw material from the earth crust. And once we take away that crude, we have a process called refining. During the extraction process, petroleum carries so many impurities. It is sent to the further process that is called refining. Initially in Gulf countries, whenever they do this extraction, the petrol will be coming in the form of crude. That is mixture of many, chemical compositions. So we have to separate kerosene, petrol, diesel, wax, grease, everything from that crude. And that process we are calling it as a refining. Okay. Now let us see how refining can be done. The process of removal of impurities from crude oil and separation of various fractions with different boiling ranges is called as petroleum, refining of petroleum. What is mentioned? Various fractions with different boiling ranges. Crude, as it is mentioned here in this chamber, there will be a chamber which is specifically meant for injection of crude oil. Once this crude oil is inserted into this heating chamber, temperature maintained somewhere more than 500-600 degrees centigrade. So based on that high temperatures, with the help of these different boiling ranges, lower boiling point having one easily travels up with this horizontal trace. There is a space between these trace, we can see here, as I am showing here arrow marks. Every horizontal tray will be having space here. With that, vapor can travel up, easily move up. So lower the boiling point, that material can easily travel up through the nozzle of this horizontal trace. And likewise, all the vapors will be traveling in their different boiling ranges. So later we have to take out those vapors and pass through the chiller. Chiller or cooler. With that, those vapors will be condensed, and finally we can separate diesel, petrol, kerosene, everything. Okay. And this refining can be done in three ways. That is the first process, separation of water through the Cottrell's method. Second, removal of the sulfur impurities. And then finally, fractional distillation. Fractional distillation is nothing but heating up the crude, and based on their boiling point differences, the vapors will be separated, and later those separated vapors will be passed through the chillers or coolers and then allowed to condense. With that, we can separate petrol, diesel, kerosene, etc. That is the process we call fractional distillation, and whole setup related to refining of petroleum. Now, fractional distillation, basically we are maintaining more than 400 degrees centigrade. Okay. And fractions are converted into vapors, and those vapors will be passed into the fractional distillation column, and later on those will be passed through the chillers, and finally we can get the condensed and separated fuels in the form of petrol, diesel, kerosene, liquid fuels. Okay. Now another process, interesting part of this liquid fuels is cracking of oils. Cracking is nothing but, once we have done the fractional distillation and extracted petrol, diesel, kerosene, from one product, bulk product, making two different useful products. That is nothing but cracking, or breaking down bulkier molecule to smaller two useful molecules. Here we can see the best example, decane C10H22. By using the method cracking, we have separated them as a pentane and pentene, two different useful compounds. This is the macromolecule, decane. From decane, we used this cracking method and we produced or separated two different useful components, that is pentane and pentene. Not only this, when we do this cracking, sucrose, bulkier molecule, can be converted into glucose and fructose. Okay, so cracking is the process of conversion of larger hydrocarbon, that means bulkier molecule, into smaller useful hydrocarbons or smaller useful components. That is nothing but cracking. Why we are doing this cracking? As per this statement, liquefied petroleum gases supply is just 2% and demand is 4%. Requirement is 4%. And then petroleum and naphtha supply is 16% and demand requirement is 27%. Likewise, kerosene, diesel, any other fuels, the supply is less and demand is more. That is why this cracking concept has come into the picture. Okay. Now, this cracking can be done with two different ways: thermal cracking, catalytic cracking. Thermal cracking, name itself, thermal, related to temperature. That means we are applying temperature and breaking down bulkier hydrocarbons into two other smaller useful hydrocarbons. So basically thermal cracking related to temperature, and that process is called Burton's process. So another second one is catalytic cracking. Catalytic cracking, definitely we need a catalyst. We all know that catalyst which enhances the reaction, which boost up the yield, that is the catalyst. So we will be using different kind of catalysts to enhance the product or that reaction. That reaction basically involves breaking of carbon-carbon bonds or carbon-hydrogen bonds. Then we will be getting bulkier, larger hydrocarbon to smaller hydrocarbon. Okay. Here we can see catalytic cracking. The aluminosilicate Al2O3, alumina, Al2O3, this is alumina. SiO2, this is silica, which is sand. What kind of catalyst we are using here? Composition of a catalyst. What is that composition? Alumina, Al2O3, and silica, SiO2, silicon dioxide. This is the catalyst we are using in the catalytic cracking. And this, not only this catalyst, metals like calcium, magnesium, iron, chromium, sodium, this can also act as a catalyst. But here in the catalytic cracking, for our fuel cracking purpose, we are using that this aluminosilicate. And this catalytic cracking broadly categorized into two types: fixed bed catalytic cracking, moving bed catalytic cracking. Moving bed catalytic cracking is nothing but fluid bed catalytic cracking. Why we are calling it moving bed or fluid bed catalytic cracking? Let us see here. Moving bed catalytic cracking is a process that utilizes small beads or pellets of catalyst to efficiently convert heavy hydrocarbons into lighter or more valuable products like gasoline. And this catalyst, aluminosilicate, will be agitated with gas temperature of such a huge temperature, that is nothing but 5500 degrees centigrade. How this is done? Let us see in this detail. The process involves feeding preheating, cracking reactor, stripping section, regenerator, product recovery. All these are the steps involved in the moving bed catalytic cracking. Now, here there is a setup to understand this moving bed or fluid bed catalytic cracking. This is the crude chamber, chamber which we insert the crude. Once crude is inserted, we will apply the temperature, and there is a catalyst insertion chamber. We can see here. This is the catalyst regenerator. Okay. Once we send this catalyst, that is nothing but Al2O3 plus SiO2. What will happen? We have to send the compressed air. Okay. What compressed air does? The raw material of crude and this aluminosilicate catalyst, with the help of compressed air, that will be homogeneously mixed like this. There is a homogeneous mixing, and this mixture of crude and catalyst will be acting as a fluid which will be easily moved with the help of compressed air. Okay. So now the crude has been mixed with the catalyst. So whatever the impurities are there in that crude oil, those impurities will be separated with the help of aluminosilicate. So impurities will be attached with the aluminosilicate catalyst. And then finally, since it is in the moving position, fluid which is in the motion, so later we can pass these fractions are based on the boiling point range differences. The fractions will be separated, vapor fractions. Those separated vapor fractions will be passed through the fractionating column and further sent to the coolers. You can see here chiller. When we pass these vapor fractions through the cooler, based on their differences, those will be condensed here. And condensed one will be separated with their boiling point ranges, and finally the petrol, diesel, kerosene, everything will be extracted. You can see here outlet of gasoline. Okay. And here gasoline, dissolved gases, and uncondensed gases, and condensed gases. Okay. This is how moving bed catalytic cracking can be called as fluid bed catalytic cracking, and the catalyst we are using aluminosilicate Al2O3 SiO2. Okay. Now catalyst movement is very important with the help of compressed air, and continuously we have to be passing that compressed air for the homogeneous mixing of this catalyst and crude oil, for the fractions separation. And then there are some advantages like simpler mechanical design, no fluidization is required, easier temperature control due to solid catalyst circulation, suitable for moderate feedstocks and refineries of smaller capacities. And certainly there are some disadvantages: lower efficiency, higher catalyst is required, and mechanical wearing is required, and replaced largely by the FCC modern refineries which are expensive. Okay, these are some of the disadvantages. Okay, thank you. Next class we will meet with some other interesting topic. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.